Hello and welcome, everyone. I am traveling this week, so I am streaming from inside of a hotel in San Francisco. But we're going to be building some packages, we're going to be fixing some CVEs, and if everything goes well, we're going to be building some Chainguard images based on Wolfie at the very end. This is the first time doing something like this. I spend a lot of time building packages, probably more than I should be doing. Uh, so I figured I'd stream some of this and let folks see how it works, see the packaging process, and get to know what it's like to pretend to be a Linux maintainer like myself. I have a couple packages prepped. I spent about 20 minutes before here looking for some stuff that we haven't packaged yet that I thought we might be able to actually get through in an hour. Some of them are from containers that are used by some of our customers or other users that we're going to be trying to rebuild with fewer CVEs. So I'll show all the tools that we use here. That include stuff like APCO or APKO, the Melange tool for building packages, a couple different container scanners for finding vulnerabilities, and the overall flow for finding these and fixing them. If I make a dumb mistake, feel free to correct me here in the chat. I do that pretty often. So jump in, and if you have any suggestions or other stuff to try if we get through all of this too quickly, which I don't think we're going to because I've got quite a few things prepped and it'll get harder as we go, feel free to drop them in chat and we can try some other packages or images. Up first, I decided to get started with this. Actually, let me remember to screen share so you don't just hear me talk the entire time. I'll share my entire screen. We're going to get started here with a CLI tool that we don't actually have packaged yet inside of Wolfie. We have a ton of development CLI tools inside of Wolfie, but we're going to get started with this one here. This is the Source Graph Source CLI. The name for this is actually SRC. It's a pretty catchy name. It's confusing when you're looking inside of the source tree because the binary's name is source, but we're going to go ahead and build this one first. This is a tool for interacting with Source Graph. I hope it'll get access to some of the sweet Cody features, which is their generative AI plugin as they roll some of that out. But we're going to jump in here and try to build this. This is a typical Go binary. It looks like in here we've got a Go mod, Go sum, there's some release scripts. The first thing I do when I want to build a new binary like this is just look around in the repo and see what the source code setup is like. Looks like we got version 5 here on the right. There's a Docker file. So this Docker file builds using Go 1.19.8. It looks like it builds a Go binary with just Go build, no fancy flags here. So this one should be pretty straightforward. And then it drops that into an Alpine image. So looks like it also has Git inside of it. Perfect, which is needed for some of the source code commands, which makes a lot of sense. So we'll build the package using Go. We'll remember to add Git as a runtime dependency for that package. So when you install it, you also get Git, and then we'll drop all of that into an image and maybe even get this published during the stream if anybody feels like reviewing my code fast enough and CI cooperates as we go. Let's try to find this existing Docker image first and just pull this and scan it and get my terminal set up and going. All right, here it is, source graph, SRC CLI : latest. Let's get my terminal going. All right, let's make this pretty large. Docker pull, let's see. Awesome, we are grabbing the image here. Pretty small, that's nice. It's gonna have Git, Alpine, those dependencies. Let's Docker run it and see what happens. Ooh, so this is actually pretty cool. There was a little warning up here, which I'll explain in a minute, and we're going to fix this as we go too. So when I did the Docker pull, it grabbed the image that was here at that tag in the Docker Hub registry. Docker Hub images and Docker and OCI images in general can actually be built multi-platform. So that means we'll have a different build for every single type of CPU architecture. This is handled transparently in the OCI protocol, and Docker for Mac has a little emulator inside of it. So it'll automatically run an image, even if it's built for the wrong architecture. So that's what happened here. This image does not appear to be multi-arch. There are ways to do with Docker files and buildx, but a lot of folks forget to do that as they're going. When I did the pull, it pulled down the AMD 64 image, even though I'm running on an ARM MacBook. So that's what this little warning is about. The tool will run, but it'll generally be a little bit slower as QEMU has to emulate those different syscalls for the different architecture. So when we build this inside of Wolfie, we're actually going to get ARM64 and AMD64 off the bat. So that's a little bit of an improvement right away once we get this built. Also scan this quick and just see what we find. There shouldn't be too much because this is a pretty small image, but let's use gripe. I have to remember to pass that flag here because this is only AMD 64. Trying to gripe and see what we find inside of this. Ooh, yeah, so they're nothing crazy, but there are a few vulnerabilities in here. In libSSL, those are some OpenSSL vulnerabilities that I recognized pretty recently. libproto, protobuf, libcurl. Oh, there's actually quite a few in here. This image must not have been rebuilt in a little while. And then some Go CVEs. All right, so this might take a little while, but we're going to get through and hopefully get all of these down to 0. Let's get started. So the very first thing I do is open up my editor here. I'll make this pretty large. And people always ask if I have a fancy script or something to get set up when I'm building a new package. My script is basically copy paste. So we're going to find something that is built in Go, hopefully something pretty similar. Awesome, like this Kyverno CLI here. We're going to copy it, new file. We're going to call it SRC, which is definitely going to confuse everyone, but that is actually the name of the tool. SRC, drop that in here. And we just kind of tweak the thing that I just copy pasted from before. So the description, source graph CLI, version field, source graph CLI. It's Apache 2 license, that's correct. Version 5.0.3. We're going to leave the epoch at 0. We bump that if we have to do a rebuild ourselves without changing the source code, if say a dependency changed or something like that. I mentioned we're going to add git here. Since we're here, we're just going to drop that in before we forget. We'll fill out a couple more things in here. This is a pretty easy Go one, so we're just going to go straight to using this YAML schema instead of trying to debug the build ourselves. We grab the commit SHA, which is tagged to that 5.0, pinned to that 5.0.3 release. We'll drop that one down in here. Switch the URL to the Git repo. Oh, and we're actually going to change this up. This uses wget to grab the source tarball. We're actually just going to get it with Git directly instead. It makes it a little bit easier to inject LD flags or build variables and that kind of thing. Change up some of this. I should have copy pasted a different one. Then instead of expected SHA-256, we do expected commit. And we have to put in the tag. Awesome. So that's going to drop in the package.version variable from up here. So it's going to clone the repo, grab that tag, make sure the commit matches up so no funny business can happen. And then we're going to do a go build. We're looking at Docker file, and we'll double check this just to make sure I got it correct. Yep, go build./cmd/source. There are no LD flags, nothing like this to inject a version. This one's pretty simple. And we're going to call this SRC. This is all pretty straightforward. Jumping down here, this is the automatic update section. So in Wolfie, I'll show some of this works in a second too as we do the build. We'll see how slow this is with my hotel Wi-Fi. This is the section that tells our Wolfie bot how to automatically update this. So it's going to watch that repo for new releases, those 5.0.4 or something like that. And then it's going to send a PR automatically if something changes. So this is the GitHub repository. We have a couple different ways, including manual, to look for these updates. So this is how it figures out the version number. It's going to strip off that V at the front of the tag and drop that into here when an auto update comes in. All right. Besides somebody eventually yelling at me about this name being too generic once I submit the PR, I think we're close enough to give this a try. So I'm going to kick off the build here in my terminal, and then assuming this is going to be a little bit slow to download things, I'll jump over and explain how Wolfie works a little bit more, how Melange works, and then how all of this kind of fits together into our Chainguard images 0 CVE image product as the build runs. As I kind of just jump straight in here to this YAML. All right, let's clear this up. I'm going to kick off the build now using my other favorite script, reverse bash interpolation. So this is going to use Docker to run this build. We have to use privileged because we do some funky sandboxing inside of the build itself using bubble wrap or QEMU. It's going to run Melange. That is the tool that we use to build APKs. So Melange, the way I think of it, turns YAML into APKs, or Linux operating system packages. The other tool that we have, APKO, turns YAML, different YAML into container images. So if this all works, we're going to get a built APK. This is the image that we're running it in. It has Melange and a bunch of other tools installed inside of it. I'm going to jump in here, change the YAML file that we're building. This is a different one I was testing yesterday. src.yaml. The architecture, otherwise I might try to do both or emulate. We're adding my local signing key here. Keyring append. We're adding the actual Wolfie one too, so we can grab some of the dependencies from there. And we're going to get started. So let's try it and see if I made some silly typo in the YAML. Oh, looks like the YAML at least parsed, so now we're downloading dependencies and running. Let's go. I'll explain how some of this all fits together. Eventually, once we get this working, we're going to submit a PR live to this repository here. This is the Wolfie dev/OS repo. This is where most of the packages that we build, especially open source ones, live. So every one of these YAML files here is a package definition. You can click on one and see it. Let's go to OpenSSL. This is a fun one. Some of them are more complicated than others. Go stuff is typically pretty easy to build. So that's why we started there. This is the Melange configuration that we use to build the OpenSSL package itself. So it's a little more complicated. We're getting the source code here directly from OpenSSL. We're checking the SHA. In this one, we're actually applying a few patches to fix some CVEs. We might have to do that here as we go. I'm going to start out just by building it, throwing it into an image to test, and then scanning for CVEs. So we might have to patch it ourselves. These patches came directly from the OpenSSL maintainers to fix CVEs that had recently been reported but hadn't been released yet. The build happens in here instead of a Go build. This uses Perl. Yes, building OpenSSL actually does use Perl. There's a bunch of Perl-generated assembly code, which then gets compiled. And that is how cryptography across most of the internet works. There's a bunch of other stuff in here, sub-packages. We split out man pages, split out libraries and headers. That's what the sub-packages section down at the bottom is. We don't have to do that. This is just a standard, simple Go binary. All right, let's see if it worked. No, I screwed up. All right, there was a typo somewhere. I should have checked earlier. Oh, yep, there's an extra closing brace. Run this again and see. All right. Let's get some stuff downloaded and hopefully built. Now, when I scanned this, I saw vulnerabilities both inside of the operating system packages as well as some in the Go dependencies themselves. We can actually patch all of those by installing different versions of the operating system packages that have things patched, as well as patching things directly in the Go binary itself. So I'll show how that one works once we get this going, because I think I did see a couple CVs that I'm pretty familiar with in those Go language level dependencies. All right, well, this runs, I can jump over and show another error. Good thing I didn't disappear right before this happened. Could not find branch v5.0.3. Let's see what I messed up. Oh, is there no V? There is no V. There we go. So that means we can take this one out and then also drop that line. A lot of repositories have a convention where they include a V in the branch or tag name. By it here. Okay. So once we get this package going, we'll try running it. Right now, I'll jump over and show some of our images that we're eventually going to build this into and publish that you'll be able to pull. So we maintain the Wolfie open source repository. All of those configurations are open source. They're there to build open source packages. Then as a service, we also build these into images and we keep those images up to date. We have a huge collection of free images, which you can see here in our catalog. We also have a set of paid images, which generally include older versions, specific versions where we backport CVE fixes into. You can see here in the Chainguard Academy how to find, how to pull, how to authenticate, and how to use these images. You can see a bunch of data that we track on the vulnerabilities in our images for some of the other ones available as well, because we maintain those SLAs and patch things continuously. All right, now let's hope that the build finished this time. There we go. All right, we actually started the build. We're doing a go build here. This is running inside of our container, so it's fetching all of these dependencies from the go.mod file, which tends to be pretty slow because there's so many dependencies in here. Hopefully this finishes in a couple seconds when we kick off. You can see that it's actually running this on the ARM build. So when you build all this locally on my Mac, we're going to get an ARM binary that we can run natively, unlike that one that I pulled, which had an AMD64 binary. All right, still going, still going. There we go. All right, the build happened. We generated the package. Awesome. Now we can see the package here got built in my local directory packages, the architecture, and then source, that fun name, which is definitely going to confuse people. See what this looks like. The extension here is .apk, but that is really just a fancy name for a specific type of compressed tarball. So we can use the normal tar command to see what's inside of it. Some information about how it was signed, some metadata about the package itself, and then the files. So these are the entries for the directories and the binary itself. So the binary is placed at user bin source. And when we unpack this inside of an image, that's what we're going to get. It should be directly on our path, which is awesome. There's also an SBOM in here. So we generate this SBOM in SPDX format automatically as part of that build. So this SBOM contains the information used to build that package. When we eventually stick this together into a Chainguard image or any other image using APKO, those SBOMs will get stitched together into a big SBOM representing the entire image itself. So that way we have SBOMs for the packages and then SBOMs for the final image too. So let's try this thing out that we just built. We have to turn this into an image. What I do is I keep this little scratch file in here, an appco.yaml that I just use for debugging, and this is copy pasted from our images repo. I keep some extra tools in here, like a shell, APK tools as a package manager in case I need to do some debugging. But overall, this one is really just for testing. We'll turn this into a real one later. Drop that bottom section. So this is going to install all these other things. We should get Git as well, because I added Git as a runtime dependency here in the source package. And actually, it'll get pulled in anyway from something else, I'm pretty sure. But we'll use APKO now to get a Docker image that we can try and play around with using Docker for Mac. So for that one, another reverse incremental bash history search. This one is for the APKO tool. Quite a few fewer flags here. Still the same architecture, otherwise it'll do multi-arch, but I only built it for ARM. Some signing keys, the local packages. I haven't actually built and pushed this up to the Wolfie registry yet, so I have to use my local package directory in here, which is signed with my local key, so that's what these are for. Here's the file. We just use that name as a convention, and then it's going to build an image with this name, cgr.dev/chainguard/test, and it's going to drop this in a tarball on my laptop that we can then Docker load in. So here we go. This one should be pretty quick. We're installing stuff. There we go. See Git got pulled in. That's cool. So the runtime dependency worked. We have the source tool. We have some keys, the base, and then we have the final image here in this tarball. Let's load this up. Docker load. Test.tar. Awesome. Now we're going to run this, and we'll add sh to get a shell. Awesome. So let's see what the command does. Ooh, it worked. So it looks like this takes some environment variables, which I don't have set, for an access token and the endpoint to hit source graph. But we got this running. We can do src version. Let's see what it grabbed here. Dev. So yeah, this is a little bit weird. Sometimes Go binaries have a way to inject the actual version number that was used into the binary, but I didn't see that in that Docker image we ran. Let's see if we missed something by trying to run that Docker image to see if it prints out that same thing, or if maybe we missed a build step that updates that variable. Pull. Okay. Version. All right, so this one has a version, but it's actually really old, 5.0.3. So maybe something changed in that script, and that's why we're seeing so many of those vulnerabilities in there, but also why I couldn't find it in the build script. Looking here for a couple minutes, but then we'll submit the PR if we can't figure it out, and then try to fix this a little bit later. Because I don't go, we're going to jump in here and just guess where the version command is. probably somewhere in here, version.go. And let's see where it gets the variable that it's going to print out. Current version, version.build tag. That's coming from an internal package here. Source CLI, internal. Version. All right, so it looks like we could use some LD flags to set this thing. And let's see if I missed it somewhere in here. Let's do a quick search. See it anywhere here in their build scripts. So we're gonna have to remember or copy paste from somewhere else the exact LD flags to set that. You do it basically based on the name of the package. So it'll be something like -x internal version dot default build tag. Let's try to find it from somewhere else. All right, here's an example of a different one. LD flags and something like that. Well, let's drop, this is from build kit. Let's drop this in here. Except instead it is something, we're gonna pass in the fully qualified path name here, which is internal dot version dot default build tag. And then this will be the template parameter for, we'll scrub that. Copilot was trying to do some fancy magic here, so let's just see what it wanted to do. I think it's probably doing that just because I had that below. All right, let's look at a couple other examples before I kick this off because it's kind of time consuming to test. Yeah, okay, I think we do need the full package name. That's what I was wondering. All right, let's go back to source. We need the fully qualified. Okay, so that should now put in the 5.0.3 when we do the build, and we'll get a working version. Let's give this one more try. And once we get this, we can do a quick vulnerability scan and see what is patched in the Chainguard image versus the upstream source graph one. We can patch anything else missing, and then we'll get this submitted to Wolfie and then to the Chainguard images catalog itself too. We might have time for one or two others. And because I'm doing all of this, I can't see the chat. So once this finishes and we scan, I'll stop screen sharing for a minute, jump over there and maybe answer some questions or see if there are any requests. There we go. All right, the build is running. Well, I will stop sharing and over to the chat for a couple minutes while we go. So there's one good question here. On images where we only need the binary, is there any advantage of building it with Wolfie instead of Scratch? Yeah, so I assume you're talking about a Go image or something like that in this case, because they're pretty easy to build into a static binary. The main difference between using Wolfie and just dropping it into a Docker file with something like from scratch in a case like this is that we will also include a couple other simple dependencies in there that you might not know you need until runtime, and it might not bite you until later. So those are basically the CA certificates. So CA certs, those are what your Go binary will use to verify certificates if, say, it tries to make an outbound network call. If you try to, download something from the internet or upload something or make an API call, you need those CA certs to make sure that you're talking to the right server. They're just a simple text file. Another one is time zone data. So that one is a little more subtle, but depending on what time zone you're in or what time zone you're trying to print or format log output in, unless there's some text files explaining called TZ data, you might get strange messages or time zones or logs printed out. Um, all right, that build finished. One more question from developer guy. Is there any option to upload the SBOM to the OCI registry along with the image we pushed, or is outputting SBOM into disk the only option for now? And yeah, well, when you do the APKO APCO build, you get an SBOM alongside the image. When you're doing that with just Docker load and the tarballs, there's no good spot to put them. So I think APCO drops it on disk. I don't know if there's an option to upload the SBOM to the OCI registry. I think there might be a way to do like an APCO publish or something, which goes directly to the registry instead of a tarball on disk, but I'm not entirely sure. I haven't tried that in a while. All right, the build did finish, so I'll put screen share back on and we can keep going. Entire screen. All right. So the package finished. Let's turn it into another image with APCO build. All those packages directly in. As you notice here, I'm just running APCO directly on my Mac instead of inside of Docker because it has native support for that now, which is pretty cool. It's just the APCO command, no Docker run. Let's load it. All right, let's run. Oh, we must have screwed up those LD flags. The hard part with those is if you get it subtly wrong, the build continues happily without actually injecting that environment variable. We'll fix that up a little bit later. We'll get this sent up so we can move on to something else. Unless somebody in chat happens to see what I did wrong. I think I know. There's probably one more thing right in here in the path if I look. We can start patching CVs at the same time. No, it is directly inside of internal version. Maybe it's slash version. All right, we'll leave that there and we'll try it as we fix some CVs. Let's do a gripe on this. And see what the packages are all fresh and should have no CVs except for the source graph binary. Awesome, and none in there either. That's perfect. I'm guessing that's because the one that I pulled down from Docker Hub was actually version 4 instead of the version 5 that's been built lately. So let's give this one more try while I start explaining the next build, just so we can send up the clean PR, hopefully with the LD flags actually working. Double check anything else to see if I screwed it up. Yeah, so here's some other examples. LD flags -x. Yeah, so this one doesn't have the full path inside of a Kubernetes image. Main.version. This one does. Let's compare this inside of kubevela. So this goes all the way up to the variable with slashes. So kubevela / version. So it should be a package name version and then somewhere in there this variable. Yep. All right, so I'm guessing it's going to work this time when I switch that dot over. Oh, it's still going. This will PR this up to Wolfie. A couple of the other things I prepped are this one is going to be pretty hard, but we're going to need it eventually someday. The SoftHSM package. So this is a C package that emulates a hardware security module for testing stuff in CI if you don't actually have one running. I did a little bit of looking right before this to see what we're going to need, and this has a couple other C dependencies, so this one could be fun for the second half to get through, because SoftHSM itself needs this library called Botan, which is some cryptographic primitives in C that we do not have packaged yet in Wolfie, so we could pull that up and build this too. This one does look pretty straightforward, and there are a couple examples from Alpine that we can read and get inspiration from if we try to build this. All right, final package here for source graph. Go, go, go. Try out the variable one more time. Still did not work. Maybe somebody in chat knows what I screwed up. I'll PR this up and leave a to-do to fix that up later. Something is close, but not quite there. Add that. We also have to add an entry here for the build system. Bottom and the packages.txt. And a little to do, so we'll come back and fix this later. Should pop up. Secure because we're using get sign. Push that up. Open up our PR. Clean up some of this template. Under an approved open source license, this is a maintained package version. I added it down there, and we can delete the rest. I'll say hi live stream. This is going to run CI. It's going to test the build. It's going to lint, and I'm probably going to get yelled at because I forgot to run our YAML formatter on it too. So let's see, call it YAM. Nope, didn't change. Awesome. We got the linting right on the first try. All right, let me just hop back over to chat, see if anybody figured out what my typo was, and if not, we can move on to SoftHSM. Oh, everybody's saying internal / version. Didn't I change that? Yeah, I changed to that at some point, and that's because they have a const. Let's see. So how is it supposed to work? Maybe that's why they don't actually have it plumbed in. Yep, it's a const, so that's fun. We have a couple options here. We could run sed or patch this or something like that. But, oh, I see. Default build tag is dev. We have to just do build tag, which is the var right below. I get it now. All right. Let's do one more build here, update that PR, and then we can move on while that runs. Good find, Dan. All right. Let's take a look through this SoftHSM one. This actually came in through a request. It's kind of a set of nested dependencies we've been working through for this bank vaults container. This looks like it's a utility from Bonsai Cloud for working with HashiCorp Vault. It's got a whole bunch of certificate renewal and other fun stuff. And as you look in here at the Docker file, like I do before, they have a couple crypto libraries, some of these CCID, OpenSC. Pretty sure we have some of these. We have CCID. Oh, we don't have OpenSC. CSC Lite libs. CSC Lite we have, and then SoftHSM we don't have. Oh, we're going to do one of these two. I then looked at SoftHSM, and we find it here. This has that dependency on Botan, which we don't have. So we can then move on to the final one in this kind of recursive dependency tree of Botan to build. So another, and it's still building. Am I actually sharing again? I forgot to start sharing. Thank you. There we go. Yes. Okay. So while the build keeps running, yeah, this is the Bank Vaults utility from Bonsai Cloud with these dependencies. So it looks like we missed OpenSC and SoftHSM so far. We'll try to knock at least one of them out today. SoftHSM is here with Botan, and the build is still running. Oh, no, there we go. All right, one last test. Go. We can find Botan, and then just look up how these things are built for other Linux distros. A pretty simple one to check against, because the Melange configs usually translate pretty well, is Alpine. So I think I have it pulled up here. Yeah, here's the Alpine APK build format, which is kind of a predecessor to the Melange configs for building packages. And this one's pretty simple. Grabs a source code at the version, it's got the license information, and we just set some C flags, run Python configure.py make, and make install. So we'll give this one a try next. Once this is done, yes, it worked. Amend our commit. Stop that now. And we'll force push. See, it should hopefully work, and we'll come back to that later. All right, next up, OTAN. Find a Python 3 configure or something to copy. Here we go. Looks like some of the nodes use a similar setup, Node.js. So let's start here with more copy paste. Filling this stuff in again. Where is that one? Photography toolkit. This is BSD2 clause. Autocomplete. Yeah, BSD2 clause. The version number we're going to grab is, I don't see any versions here. Oh, here we go, text 3. I don't need most of this. Do we had in Alpine anything fancy? Python 3, so bzip. Oh, that's for dev. Boost, cdev, zlibdeb. Zlib. Dev, is that what we call it? Yeah, there we go. And I think it has OpenSSL, right? No. SQLite dev. Let's grab that what it's called. There we go. Okay. And actually, I'm going to show a different workflow for building this one, because it's going to take a little while to iterate with in Melange if I screw it up. So we're going to just pull up a Wolfie container and do this interactively first. So I'm inside of a Wolfie Docker image right now, and we're going to try building this ourselves just with Git and these commands before we translate it. With Go, you can get away with skipping that sometimes, but we're going to take all of these. I'm just going to drop these into the command line as a list. Looks like I got something wrong in the boost package. Boost. Oh, this is a fancy one. It's screwed up here. Boost. Might have to come back to this one. Yeah. All right, we'll come back to this one. Something screwed up with our boost package. Let's try, instead of Botan. All right, well, first let's make sure it needs boost. Sometimes this stuff shows up in here even though it's not needed. With boost. We can try without boost and add that back later. Have everything in here except for boost. we're going to do a git clone and just try to run some of those commands ourselves. So Python 3 configure, and then all of that just without the boost one. And yeah, this takes a while to install these tools, so that's why I'm doing this once instead of having to run this in every Melange iteration. Okay, so I've git, oh, forgot git, we need that to get the repo. Where did the repo go? Oh, this is a big one. Don't tell internet, it's actually been pretty fast so far. While that runs, let's check and see if it went in. Oh, all the tests passed. And nobody's reviewed it yet. I'll just click that so that when somebody does review it, it goes through the merge queue and gets merged. I'm pretty sure somebody with approved rights is watching the stream. All right, here, where is the build script? Okay, so we'll run Python configure. We'll just drop the with boost part. What happens? Oh no, something screwed up copy pasting. Tabs and spaces mixed up. But yeah, that's it. Close. No such option with OpenMP. Right. I think it's because Alpine probably had version 2 and we're trying version 3. Try again. Right, something worked. Now let's try make. It's compiling. Let's try to translate this over here. We dropped boost. Check out again, swap that over. E. Fix up our tabs to spaces. Indent. BZlib. Something broke. Do we have BZlib? Bzip? Yeah. Did I not install that? bzip2-dev. That's what we call it. APK that one in. Make one more time. So far, we've done a Go app and a C app. The worst by far are the Python apps. I can never figure out the Python packaging ecosystem. That works. This looks pretty straightforward. We'll toss in a make install at the end. Then we can try this all in Melange. We can drop that out, use our built-in make. Got make install here. Drop that. Up these variables. Repository. Expected commit. Throw in the auto updates. In this case, the tag is still just raw releases, so we need to use tag. This is still running. I love this one. Of course, Botan is being built. That's what I told it to do. All right, while that runs, let's see if someone merged the PR. Hey, it worked. That is in. So what's happening now is this is getting built on both architectures. There should be a GitHub action running now to build this on AMD 64, and then another one building it on ARM 64. They run on different build systems, so they're both going. Let's see what happens. It takes a little bit. We can kind of follow along here. Build packages production 1 minute ago and 1 minute ago. Yeah, it probably takes about 5 or 10 minutes to get that package into production, and then we can start up a Wolfie image and do apk add src, and that'll work. Cool. This is still building. The built-in make little pipeline that we have here, this thing autoconf make, should be setting the -j parameter to use multiple cores. I just ran make by itself to keep things simple while I was debugging, so I'm guessing it's just using 1 core on my fancy MacBook M2. Check. Yeah, so just 1 CPU, so this probably would have gone faster if I did -j8 or something like that. Hopefully we're close to done. Should I kill it? Hop back over to chat while we're running this and see if there are any other questions. We have about 10 minutes left. Question for Go: would it be reasonable to pass -s, -w, -trim path, etc. flags to LD flags to strip the package, even if maintainer is not used in the upstream repo, or should we respect the LD flags that are already set in the upstream? It kind of varies. We usually strip things just to keep them small. I think the built-in strip action will actually do the same, and we pass that on most of our packages. So I don't think you actually have to pass it to the linker. I think just running that strip pipeline will do the same thing. Another one, are the packages included on the final image? If so, is there a way to limit the packages we include on the final image if we only need them for building? No, they are not. So that environment section in the Melange config is just for build time dependencies. So that's why it's nice for building slim images at the end. That installs those just to build the package, and then only the things in the runtime dependencies section get added to the final image. So that would be a case where like the Git program is needed by the source graph CLI in that last package we built at runtime because it uses it as like a sub process or something. Melange will also auto detect stuff like shared library dependencies. So if you build a Go app that needs libc or something like that at runtime, it will auto detect that and then automatically add that as a runtime dependency for you, so you don't have to think about it. Is Wolfie Melange app code more towards building tool and base images, or would you also recommend using it for building our application images? Mostly we recommend it for publishing tool or base images that you're going to be publishing to your users. If you have a first party app, I would use something like Co or Jib or some other tool to get your application thrown on top of that base image. The reason I usually recommend, you could use these tools, they add a little bit of friction. They slow down the development loop a little bit because you're going through some extra steps to get an image. The big benefit you get out of using Melange and APKO is that you'll get a package for your application that you're trying to build, which means scanners will detect it correctly. It'll make it into SBOMs a little bit easier. There's not really a huge benefit there for internal stuff because scanners detecting your internal application isn't that important unless you're publishing CVEs or something like that against the internal app. So it's generally not worth it in my opinion, unless it's something you're publishing for third parties or something open source like that. If it's something you're iterating on daily, then I would use a different tool like Co, depending on what the language you're building is. This is still building. I probably should have canceled this and ran it with better parameters. But let's just assume that works. And I'll get my screen share going again so I don't forget. Yeah, I'll cancel this just because we have 10 minutes left and rerun it inside of Melange so we can see if it works. Include everything in there, the bzip. Yep. All right, let's give this a try. No silly syntax or errors. It's actually kicking off. Awesome. But we do have to install all of these tools like the compiler a second time. That's going to take a little bit longer. Really quick, I'll jump over to our images repo and show what the next step would be if we did want to publish these directly into a Chainguard image. We can also see if the CI build finished yet. Nope, a couple more minutes here, but as soon as these finish, we should be able to start up a Wolfie base image and APK add source. But if we did have time and wanted to turn this into a full Chainguard image, we would come into here into this repository, the images repository. We would do some more magic copy paste, find an image that looks a little bit similar, grab the directory. Each one of these directories represents an image that we're building. Something like cosine might be pretty straightforward or similar to this one because it's just a Go app. We would add in an AppCo YAML. This is similar to that one I was using instead of my Wolf repository, just that Scratch one. We would add in source here instead of cosine. This section configures it all to run as a non-root user, which is pretty important, especially for servers that are going to be running in a production cluster. It's the entry point to be user bin src. For the command, the default command, if you just run the image without anything, it could be help or version or something like that, depending on what the command has. We'd write some documentation in here and readme explaining how to run it, what it looks like, if there are any variants. Sometimes we have multiple versions of an image, one with a shell, one without the shell, depending on exactly what its use case is. So we document all of that. We'd show how to use it, some usage samples here. And then the fun part, tests. Depending on exactly what the image is, we can write some tests for it. For a CLI tool like this, there's really not a huge amount you could do. Maybe we could throw in a secret Sourcegraph API token or something like that into CI, but that gets a little bit tricky to make sure that we can actually contact the API. At that point, we'd probably be testing the API more than the CLI itself. So for a lot of these simple CLIs that interact with external services, we just start them up to make sure they don't crash at runtime, to make sure that it compiles correctly. We grab the shared library dependencies and that kind of thing. I screwed it up. I left the V here in this tag, but I removed it from the other one. Off one more, and I'll probably just jump over to questions since we're wrapping up and hope that this one finishes and you can follow along and see if I get this PR sent up to the repository later. What other questions do we have in the chat? Nothing? All right, well, oh, CI finished, almost. CI finished on AMD 64. So I should be able to share my screen and do a Docker run with that image and then install the package to make sure everything works. I will start up an AMD 64 image to do that test and hope it works. The ARM one is still going. Linux AMD 64. We're going to have to download that version of it. Yes. Okay. So all these dependencies here, the PCRE, OpenSSL, curl, these are coming from the Git tool itself because we have that Git runtime dependency. See, hey, it worked. It's a little slow because we're emulating AMD 64. The version number, everything is good. This build is still running. It's definitely going a little bit faster. Let's check the stats and see if it's using more than one CPU. Yeah, there we go. We've got dash J14 or something like that. So a lot faster than a single core. All right. Well, thanks everyone for joining and watching me screw up YAML and bash. And it's been a long time figuring out where the typo was in my Go LD flags for that package. But now we have that package and we should be able to get that up into an image pretty soon too. So that was it for today. We'll probably do more of these in the future, and we can take more requests and try to build more stuff on the fly, although it might or might not work depending on internet speed. Thanks, everyone. Have a great afternoon.